Hi, everyone. So this video is going to center on a really cool data set that was collected at Lone Star Geyser in Yellowstone in the years 2010 and 2014. So this right here is the geyser cone. And what I'm overlaying here is a representation of what the subsurface... Can you pause this for a sec? Oh. What? All right. In a second. All right, thanks. Pause here, please. Thanks. Okay, so this is a representation of what the subsurface plumbing system looks like beneath the geyser, or what we think it looks like. And the main thing to take away is that there's this cavity that's offset from the vent. And we think that's important because it allows for gas and pressure to build up in the system, which then leads to these episodic eruptions. You're good. Lone Star Geyser is like many other geysers in that it erupts with remarkable regularity. So this is what the cycles look like. It's showing 10 hours of data and 3 eruption cycles. So at the top here, this is the temperature at the vent, which is a proxy for the amount of water discharge. So an eruption, you can tell that there's an eruption by this broad peak up here. And so you can see that there are these 3 eruptions. In the middle, I'm showing the location of the hydrothermal tremor. So the tremor in geyser systems is thought to reflect bubble nucleation or collapse. And so we see that there's this sort of persistent location of tremor during the cycle. And then just before an eruption, the tremor will migrate towards the geyser vent. And this persistent location corresponds to that bubble cavity that I showed earlier. And then on the bottom, we have tilt data. So this is showing you how the ground is deforming. And that's maybe reflecting the motion of subsurface fluids during the eruption. Great. So these time series graphs are kind of hard to always to figure out the relationship between different... Hang on. Yeah, can you pause? Oh, it's fine. Okay. So sometimes it can be difficult to understand the relationships between different data types when you're just looking at these time series graphs. And so we're going to look at a different way of understanding that data using data movies that make use of sound as well as visuals to try and understand the relationships between different data types. Thank you. So this is the Keeg that's going to show us what the movies look like. So that's for water discharge, or the temperature at the vent. No, just turn it down a bit. Oh, that's on. Thanks. Okay, great. So now that you guys know what the different sounds and visuals are corresponding to, now we're going to put it all together and listen to 3 eruption cycles in 2010 and then 3 eruption cycles in 2014. Okay, so we wanted to look at how stable this kind of system is over the course of from 2010 to 2014. So now I'm going to play those two videos side by side so that you can sort of directly compare how the eruptions line up between the different years. Pause. Thanks. All right. So it's really remarkable that I don't know if you guys could pick out the eruptions when they were happening, but between both of the years, the second eruption happens at exactly the same time between the years. But then it's also interesting that the last eruption of 2010 seems delayed relative to the eruption in 2014. So there's something that's making these eruptions extremely regular, but then there is also the ability to modulate that regularity and delay some eruptions. So now, one other question that comes out of these movies is that even though the eruptions happen very regularly, the pre-play, so those sort of surges in activity just before the eruptions, those were really irregular, and those seem to happen at completely random times in the different years and the different eruption cycles. So that's another question, is what's causing the eruptions to be so regular, even though the sort of lead-up activity seems to be very irregular. So for the final movie, we're going to zoom in on just one eruption cycle so that we can listen to the details of the eruption cycle. Yeah. Oh, that was bad. I think it's quite close to the end. Thanks. This is that pre-play that I was talking about. And this is the eruption. All right. Thanks very much, everyone. If anyone has any